So hope the audio is okay. And today we are going to understand about an exploration of Olympiad Combinatorics by Rushil Mathur. We'll just try to explore what is then the book. And we'll start with the initial discussion. So uh, basically here what we can say, I'll just mention the topic name here first. Topic name I'll just mention, try to mention it. Introduction to an exploration of, basically I'll try to explore about this particular book and exploration of Olympiad Combinatorics. Okay, so this is the topic or name of the book by Rushil Mathur. He is an IMO gold medalist. Okay, and he's written a book, and I was very curious to know how he wrote the book and what is then the book actually. So basically the book Exploration of Olympiad Combinatorics is authored by Rushil Mathur. Is studying. He was studying earlier by in the grade 12 from Mumbai, and he have a passion for mathematics, and he's clear in more. I can say 3 times, and further, he has leads the Sufi Fellowship for Olympiad Mathematics and is instructor at Olympiad Otis program also. So that is the thing. And there are some reviews by this, not just another book on combinatorial mathematics. It has its own style and distinctive quality. It should be very useful for Olympiad aspirants who want to learn the subject by Dr. C.R. Panescher. So everyone knows about Dr. C.R. Panescher, right? So it is about him, I can see, right? So we will try to explore about it more. Okay, we'll try to explore more about it. I can say more explanation I will do. We'll start with the first point: introduction to problem solving. Olympiad mathematics is all about solving problems, and in general also I can say that it is about problem solving only, right? So, but these are different from the problems you would see elsewhere in school. Most problems here are unique because solving them usually require I think innovatively and out of the box. So that is the thing. The key idea on which the Olympiad world is based is that a person with minimal formal math education should be able to understand the solution. Still, every graduate, even graduates in the subject, should struggle to find a solution. Okay. The key idea on which the Olympiad world is based is that a person with minimal formal math education should be able to understand the solution. Still, even graduates in the subject should struggle to find a solution. So, understanding of the solution can be done by any formal education, we can say, but for solving that problem, obviously the graduates will also find difficult. Often the problems you would see in this Olympiad and in this book will be such that even people around you who are not really into math can understand them. Often the problems you would see in the Olympiad and this book will be such that even people around you who are not really into math can understand them. This makes these problems a more genuine test of your thinking skills and intelligence rather than knowledge. That being said, Olympiad are trainable. Olympiads are trainable to some extent, or else why would I write this book? Obviously, by Rusmat is mentioned. By trainable, I mean that experience with a wide set of problems can improve your intuition to a standard where even out of the box problems feel like they were in your box. Okay. And through this book, I aim to make your box bigger too, and show you some amazing and beautiful problems that hopefully find a place in your mind forever and help you discover the beauty of the subject. On this note, some fun problems have been added in the next section. The first five require nothing but common sense and very elementary mathematics. The following five are slightly more tricky and will put you logical skills to the test. Gradually, the problems become tricky and require deep thought, but their solutions only need elementary math. Hints have been added to the problems, but I strongly recommend thinking about the problem for some time before using the hints, obviously, right? So, okay, one I can say the thing is that, uh, by the way, the number written after hint is the hint number. Okay, you need to refer to the into the appendix at the back of the book if you want a hint on the problem. Okay, that is good. Because whatever numbers they have given, if you just to see the hint directly, it will not be very good. That is why he has kept logically is a very good technique, I can say. He has written the problems on the page number 3 that, by the way, the number written after hint is the hint number. You need to refer to the in the appendix of the at the back of the book if you want a hint on the problem. Okay, let us start with the first problem. Let us see if we are able to solve it or not. We'll just check it. So, problem number 1. Problem 1. Okay. So, what is the problem 1 here? A number a number a number of bacteria a number of bacteria are are placed in a glass 1 second later 1 second later means after some 1 second, each bacterium each bacterium divides into two, and the next second each of the resulting resulting bacteria resulting bacteria divides into two again. I think writing this is a long process. I'll not write it. I think it will not be. It's very unnecessary time wastage, or you can say involvement. I'll just read the question and try to understand it, and then I'll just go for the solution directly. So for that, you need to purchase the book, obviously, right? So the question is that a number of bacteria are placed in a glass. So let us say a glass is there with us, like this. Let us say any glass is there with us. Okay. Now we don't know what is the number of bacteria. Okay, some number is kept here. Okay. Let us say a number of bacteria are placed in the glass. 1 second later, each bacteria divides into two in the next second. So at 0th, let us say X number is there. At first second, we have 2x, the quantity. Each bacteria divides into two, and the next second, each of the resulting bacteria divides into two again. So second, at second, it's divided into two. You can say 2 will be applied to the last part, obviously. 2 for 2x basically. After 1 minute, the glass is full. We're saying that after 1 minute, after 1 minute, glass is full. Glass is full, as we can say. When was the glass half full? Okay. When was the glass half full? That is the question asking. When was glass half full? So that is the question given. Okay, when was the glass half full? So at starting we have, let us say, x, and as first second we have 2x. After 1 minute we have the glass full. So let me just calculate briefly about it. Okay, so it means that after 1 minute means there are 60 seconds. After 60 seconds we have glass full. Glass is full. Okay, and after 60 seconds means you can say x, 2x, 4x, 8x. So the sequence will go there as x, 2x, 4x, and it is 8x, 16x, okay, 32x, like this, and it will go till the glass is full. So I can say that it is a, you will take x common outside, obviously it will be 1, 2, 4, 8, 16, 32. Like this it will go on, and then obviously I can write few things here. It is a GP, obviously it looks like, so we'll just check it. Yes, GP. So 1, 2 to the power 1, it is 2 to the power of, this is 2 to the power of 0, 3, okay, 4, 5, like this we will move on. So here basically it is a GP. Actually we can say there is no confusion in this. This is a GP. So further this will, you can say, lead to, further this will lead to, so we have a GP where first term is 1, and let me just check it, because okay, about this part. Okay, we'll check it. Okay, GP we are having, and how the GP progresses, that we have to see. Obviously the terms of a GP are obviously is going like this fine. $60. So here I can say that it is 2 to the power 0, 1, 2, 3, 4, 5. It is going like this. So this term number 1, first term, second term. So I can say that the 60th term will be 2 to the power 59. Okay, 59. So 2 to the power 59 is the 60th term. So after 1 minute, after 1 minute, this will be, you can say it is 2 to the power 59. Okay, this will be there with us. 2 to the power 59 will be there, and in the glass is full here, full glass. Okay, and we need half glass actually, so let's divide by 2. Okay, so generally in the initial contents, whenever you say full glass in 1 minute, so half glass will be in 30 seconds, and then we can proceed. I think that is initially we think, but that is not the case here, right? Glass is half, full glass is 2 to the power this much, so glass is half. We can say here this will be 2 to the power 58, which is actually 59th second. Okay, 59th second. So answer can be glass was half full, glass was half full. 59th second. We'll check the answer. If it is correct, then it is very good. Otherwise, we'll just try to understand how it can be done. Okay. So there are no grudges here. We learn from the mistakes. Everything can be, you can say, kept. No. So where is the key here for this? I'll just check it. To cross verify the answer, so let me just take it. So hints are given here. Okay, solutions are given in B. Okay, let me just check it. Appendix B. Answer key is not given. Why? What is the answer? Again, second is the answer for me. I don't know whether it's correct or not. So hint number 5 is the answer is not 30 seconds of which is correct. What would have happened just 1 second before the minute was completed? I think that is the answer maybe. So that is given. So answer is not given as a problem. How can I verify that whether the answer is correct or not? It is correct, but I have to justify actually. So there is no issue. Okay. So this answer is correct as per my knowledge. Okay. This question, the answer is correct as per my understanding. So we'll just yeah, we'll just keep it here like this only. Okay. Till now I'll not publish anything. I'll just keep it with me only. And the reason why I'm keeping with me is there's no reason actually. There's no reason why I'm keeping here. So I'll just try to close up the stream now.